The radius of a circle is increasing. At a certain instant, the rate of increase in area of the circle is numerically equal to twice the rate of increase in its circumference. A. What is the radius of the circle at that instant?
So part A is asking for the radius of the circle at a certain instant. In order to do that, we got to find the derivative of the area and set it equal to 2 times the derivative of the circumference. The formula for the area is pi r squared, and the formula for the circumference is 2 pi r. And the derivative for the area is 2 pi r, and the derivative for the circumference is 2 pi. We set it equal to each other and isolate r, and r equals to 2 units.
B. Assume that the circle is a cross-section of the sphere passing through its center. Calculate the change in volume of the sphere using the radius found in part A. If the area is changing at a rate of 12 pi square units per second at that moment.
So this question is asking for the change in volume of the sphere at the moment when r equals 2. So the givens are that r equals 2 and dA over dt equals 12 pi. The equation for volume that we start with is that 4/3 pi r cubed, that v equals 4/3 pi r cubed, and we have to derive this to find the change in volume. But we need to find dr dt first, so in order to find that, we have to use the area equation, which is a equals pi r squared, and from that equation we get that dr over dt equals 3. Once we plug that into the dv dt equation, we get that dv over dt equals 48 pi units cubed over seconds.
C. The surface of the sphere is to be painted with a spray paint that will cost 17 cents per inch squared. If the radius is measured in feet, calculate the cost of painting the sphere at that instant.
This part of the problem asks us to find the surface area. So the surface area of a sphere is given by the equation 4 pi r squared. Plugging in all our variables, we get the surface area to equal 50.265 feet squared. The cost of painting it is given in inches squared. So to convert feet squared to inches squared, we use the two conversion rates, 12 inches per feet. Once we get the surface area in inches squared, we just use the cost per square inch to find the total amount to spray paint the sphere.
Hi, I'm R. I'm in the first and second quadrants.
Hi, I'm S. I'm the shaded region.
Let R and S in the figure be defined as follows. R is the region in the first and second quadrants bounded by the graphs of y equals 3 minus x squared and y equals 2 to the x. S is the shaded region in the first quadrant bounded by the two graphs, the x-axis and the y-axis. A. Find the area of S. In order to find the area of the region S, I divided it into two parts. So it'd be from 1 to 0, it's 2 to the x dx. And then I added it to the second part, which is from root 3 to 1. The equation is 3 minus x squared dx. That comes to 1.443, and I added that to 0.797, and that equals to 2.24. Find the volume of the solid generated when r is rotated about the line y equals -1. So for part B, in order to find the volume when r is rotated about the line y equals -1, you have to do this equation where you subtract the first one, 3 minus x squared, to the x, but you add +1 to both equations, and that comes to pi times 20.0875, and it comes to 63.107. And we got the interval by finding the x in this equation. The region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is an isosceles right triangle with one leg across the base of the solid. Write but do not evaluate an integral expression that gives the volume of the solid.
I'm rotating about line y equals -1.
So for part C, to find the volume of a solid, we need to do half times 3 minus x squared minus 2 to the x and quantity squared dx, because it's top minus bottom, and to get the integral, it's again to set them equal to each other and find x.
The rate in calories per minute at which a person using an exercise machine burns calories is modeled by the function f of t, whose graph is given. F of t equals negative t cubed over 4 plus 3t squared over 2 plus 1 on the interval 0 to 4. The remaining portion of the piecewise function is depicted using linear segments on the interval 4 to 24.
Vivek, it's been 22 minutes.
Oh, really? I wonder if my calorie burn is increasing or decreasing.
I don't know, you tell me.
Find f prime of 22. Indicate units of measure. To find f prime of 22, what you do is take the original function f and take the values of f of 20 and f of 24, which are 15 and 3, over 20 minus 24, which gives you negative 3 calories per minute squared. For the time interval 0 to 24, at what time t is f of t increasing at its greatest rate? Show the reasoning that supports your answer. The question asks for when f is increasing at the greatest rate on the entire interval, 0 to 24. Looking at the graph, we can see that f is increasing on the interval 0 to 4 and 12 to 16. So for the interval 12 to 16, since it's a constant rate of increase, and the derivative is constant, we can just calculate it using f of 16 minus f of 12 over 16 minus 12, which eventually, through computation, equals 3/2. And again, you can do this because f prime is constant on this interval, 12 to 16. For the interval 0 to 4, we can use a second derivative to see when f prime of t, which is negative 3/4 t squared plus t, is at a max. The way we calculate this is by setting the second derivative equal to 0. Second derivative is negative 3/2 t plus 3. This happens to equal 0 at time t equals 2. Then using sign analysis, over here we can see that time t equals 2 is a max of f prime. So the max of f prime on 0 to 4 is time t equals 2. Then plugging in 2 into f prime, we can see that the rate of increase at this time is 3. So on the interval 0 to 24, f is increasing at its greatest rate when time is 2, because f prime of 2 is greater than the rate at 12 to 16.
It's been 18 minutes. This play's not working. How many calories are I burned?
Find the total number of calories burned over the time interval 6 to 18 minutes. The question asks to find the total number of calories burned on the interval 6 to 18. To do this, we have the rate at which calories are burned. So all we have to do is integrate it to find the total number of calories burned on the interval 6 to 18. We have a picture of the graph. So what we can do, since integrating just finding area under the curve, we can use geometry to find the area. So what I did is we used a rectangle here, a trapezoid here, another rectangle, and then just using the dimensions of those shapes, we found the area under the curve to be 132, and in this application to be 132 calories burned over the interval 6 to 18.
This is too slow. I'm gonna change the setting so it'll make it faster.
Whoa, why is this so fast? Who changed the settings?
The setting on the machine is now changed to that the person burns f of t plus c calories per minute. For the setting, find c so that an average of 15 calories per minute is burned during the timer interval 6 to 18 minutes. The current average rate at which calories are burned on this exercise machine is 11 calories per minute. That's found by taking the total amount of calories burned over the interval 6 to 18 over 12 minutes, the difference in the difference from 18 to 6. Since we need the average to be 15, all you have to do is add 4, which is C.
car travels on a straight track during the interval 0 to 60 seconds. The car's velocity v measured in feet per second and acceleration a measured in feet per second are continuous functions. The table above shows selected values of these functions. A. Using appropriate units, explain the meaning of the integral of the velocity's absolute value from 30 to 60 in terms of the car's motion. Approximate this using a trapezoidal approximation with 3 subintervals determined by the table.
So the integral represents the distance that the car traveled in feet from t equals 30 to t equals 60. To find the trapezoidal approximation, you have to, one way that helps is to graph it out. And delta t represents the height and the base is the velocity values. And for these, there's triangles, so you can use the area formula for triangles, and that is shown here. And once you add up all those areas, you get 185 feet.
B. Using appropriate units, explain the meaning of the integral from 0 to 30 of acceleration in terms of the car's motion. Find the exact value.
So the integral from 0 to 30 of area represents the change in velocity of the car in feet per second from t equals 0 to t equals 30. So the integral from 0 to 30 of area equals the integral of 0 to 30 of v prime. And to find this, you do v of 30 minus v of 0, which results in 6 feet per second.
C. For 0 to 60, must there be a time t when v of t equals -5? Justify your answer.
Since the function is continuous on the closed interval and v of 35 equals -10 and v of 50 equals 0, by the intermediate value theorem, there must be a point where v of t equals -5 on the interval 35 to 50.
D. For 0 to 60, must there be a time t when a of t equals 0? Justify your answer.
Since v of 0 and v of 25 both equal -20 feet per second, the mean value theorem guarantees that a of t equals v prime of t equals 0 on 0 to 25.
Hey, do you guys need tickets for Teletubbies?
Yeah.
Here you go.
Wait. Did I hear Teletubbies?
Yeah.
Oh my god!
Here you go.
Concert tickets went on sale at noon, t equals 0, and were sold out within 9 hours. The number of people waiting in line to purchase tickets at time t is modeled by a twice differentiable function L for on the close 0 to 9. Values of L of t at various times t are shown in the table above. Use the data in the table to estimate the rate at which the number of people waiting in line was changing at 5:30 p.m. t equals 5.5. Show the computations that lead to your answer. Indicate units of measure.
Part A is asking to estimate the rate at which the number of people waiting in line is changing when t equals 5.5, but the table, since the table shows the number of people at a given time, we have to find the derivative of that. And to find L prime of 5.5, you take L of 7 minus L of 4 over 7 minus 4, which equals to 150 minus 126 over 3, and that equals to 8 people per hour.
Use a trapezoidal sum with 3 subintervals to estimate the average number of people waiting in line during the first 4 hours that tickets were on sale.
Part B is telling us to use the trapezoidal sum with 3 subintervals. In this equation, you can see this one is the first subinterval, this one is the second subinterval, and this one is the third subinterval. And this is all within the first 4 hours. So hence this is why the denominator is 4. So if you calculate that out, you get 1/4 times 151 plus 332 plus 138, which equals to 155.25 people.
For 0 to 9, what is the fewest number of times at which L prime of t must equal 0? Give a reason for your answer.
Since L is differentiable on the closed interval 0 to 9 by the mean value theorem, which implies that on these different intervals that that it is positive or negative L prime of t. So it implies that, for example, on the interval 1 to 3, L prime of t will be positive. And since L is continuous on the interval 0 to 9, The intermediate value theorem implies that L prime of t will equal 0 for at least 3 values of t on 0 to 9, which are shown by somewhere around 3, 4, and 7.
The rate at which tickets were sold for 0 to 9 is modeled by R of t equals 550 t e to the t over 2 tickets per hour. Based on the model, how many tickets were sold by 3 p.m. t equals 3 to the nearest whole number.
So for part D, it asks for the rate at which the tickets were sold from 0 to 9 inclusive with this modeled equation, and it's asking to find it from 0 to 3 hours. So in order to do that, you do it by an integral from 3 to 0 and r of t dt. So you find the antiderivative of that, and you get 972.784, which you can round up to 973. So there were approximately 973 tickets sold by 3 p.m.
That was really bad.